For the second question, they have said define cyclic group and show that every cyclic group is abelian. For definition of cyclic group, a cyclic group is a group that that can be generated from a single element, which is called the generator. For that, you can just check your note for the definition. So let's focus on the other part of the question, which is showing that every cyclic group is abelian. When I see questions that have like show that in, I first understand what the question is. What this question is saying is that we show that every cyclic group is abelian. What does being abelian mean? Abelian means that a group is abelian if when you pick any two elements from that group, it is commutative. What does commutativity mean? It means that if I pick elements A and B in G, AB is equal to BA, which means I can, if I change the order of the multiplication, if I just say A times B is equal to B times A, something like that, or A plus B is equal to B plus A, depending on if you're proving commutativity for addition or multiplication. So now here, this is where I want to arrive at. I want to show that any group G that I pick, for every element A and B in G, AB is equal to BA. Understanding that would let us know how we're going to go in the question. Now, how do we start the proof? We let G be any cyclic group. Then, from the definition of cyclic group that you know, since G is cyclic, right, it must have generators. And what are the generators? Generators are what you can use to express what you can use to generate the order. Just by the name already even, gives it away. It's used to generate every other element of the group. So now they said if G is a generator in G, then every element in G is an integral power of G. What does this mean? It means that G can be expressed as this sign here, which means that this small g can generate every other element in G, which they expressed here. That means G is equal to G raised to power n for all n in Z. So now, if we let's just pick arbitrary elements A and B in G, right? A can be expressed as G raised to power n, and B can be expressed as G raised to power m for all n m in Z. What does this mean? It means that since every element can be expressed as a power of G, we can just pick any power. This n can be 1 when m is 2, n can be 3, m is 4. Like, there can be any number generally, just like in the set of integers. So I will now start by saying A, B. Why am I doing this A times B? Is because of where I'm going to. I want to prove that AB is equal to BA. So I'll start with AB. I have AB to be equal to G raised to power n times G raised to power m. Law of indices, this can be expressed as G raised to power n plus m. And as we know, n plus m can be written as m plus n as well. So it's the same thing as G raised to power m plus n, which then we now reverse the law back. What we did here, we reverse it back to give us G raised to power m times G raised to power n. And then, remember that we said that B is G raised to power m, B, A is G raised to power n, A, which is why we have BA. Now we have successfully proven that AB is equal to BA. This is a very nice proof. So since AB is equal to BA for all A and B in G, and note that it's very important to add this for all A and B in G because we did not just pick any A at all. We made sure that A and B were in G, and that's why we're able to express them as G raised to power n and G raised to power m because G is our generator. So we're just using the definition and the definition of a cyclic group and the definition of an abelian group, or when a group is abelian, to prove this. So since we've been able to show that G is abelian, and that's it.